Good morning. Okay, today seems that everything is okay. I didn't record the lecture yesterday because I just got too busy, and we still have quite a bit of time, so we can just have the lecture today. Today we will finish off on sequences in series, and then we're going to go backwards a little bit and look at the graphs, and then we should move on to the very last topic. Let me see, let me just look for something. Okay, so today we will look at the sums to infinity. These are not difficult at all. What we have with these is you have a sequence, and then you make it a series by adding all the terms that you have in the sequence. You add the first one to the second one to the third one, and so on until you get to the end. Okay. By the end, I mean your end terms. Now, some sequences you want to find out what is going to happen if you keep adding. That means you're going towards infinity. Now, the sum to infinity is denoted like that, S with a subscript of infinity. And the formula is just this, A over 1 minus R. This is for a geometric sequence. With an arithmetic progression or an arithmetic sequence, you cannot work out the sum to infinity because the terms are either getting bigger and bigger or smaller and smaller. So it means they are either just getting towards infinity or they are going towards minus infinity. So with one like this is 1 plus 2 plus 3 plus 4 and so on. You can't say eventually the numbers are approaching a certain number, okay? Because these are just getting bigger. You keep adding a number that is bigger and bigger. Unlike if you look at a geometric progression that looks like this. This is 1 plus half plus 1 over 4 plus 1 over 8, and then you keep going in that manner. So you can think of it like a cake, for example. So first time you take the half of the cake, then you take the quarter of the cake, then you take up that, then that part. So you're always taking half of what you have left. So when you look at it, eventually what you're going to reach at is just the whole of the cake. Unlike with this one here, it's like you add one cake, then you add 2 cakes, then 3 cakes, and so on. Okay, so this geometric progression or sequence is convergent. Okay, and then this one here is divergent. So divergent means it doesn't approach a specific number. Convergent means it goes towards a specific number. If you keep adding, like you can even try it on your calculator, add the first 20 terms, add the next one, you can see, okay, these numbers are getting closer and closer to a specific term. Okay, so the formula, like I said, is given by this, and this is for a geometric progression. Now with the geometric progression, not all progressions are convergent. Some of them diverge. Now how do we know when a sequence is divergent or convergent? What tells us whether it is convergent or not is actually the common ratio. So if we have our r, the absolute value of r is less than 1. Okay, so this means we know how to solve absolute values. This means -1, like this. So if you have an r that is between -1 and 1, then your your geometric series is convergent. Okay, so if on the other hand you have an r which is greater than 1, then your series does not converge to a specific number. So examples of those are these ones: 2 plus 4 plus 8 plus 16, and then I say what is the sum to infinity. This one, even without working out r, you can tell just by looking at it, because I'm adding numbers that are getting bigger and bigger. So obviously the final answer will not be 20, maybe it will not be 1,000, because eventually I will add a number that is bigger than 1,000 and I will pass 1,000. Okay, so here we can work out the value of r. So r, what I do is I take the second term and then I divide it by the first term. I could also take the fourth term divided by the third term. Same thing with the third term divided by the second term. So here my r is 2. Now absolute value of 2, this is just equal to 2, and this is not less than 1. Therefore this sum to infinity does not exist. Okay, so it doesn't have a specific sum to infinity. Now we can look at another sequence. If I have 16, 8, 4, 2, and so on. Now here I work out what r is. R is equal to 8 divided by 16. This is equal to a half. Now here, my absolute value of half, this is less than 1. This is what we want. So this sum to infinity exists. Now the reason it exists is because of this condition that we have over here. So that is like your check. Does it exist? Does it not exist? So you might get questions where it does not exist. Now, if it doesn't exist, it doesn't mean you can't use the formula. The formula will still, you will still be able to substitute values into the formula, but the answer you get is not the actual answer. So this formula works when this condition is met. Like you see over here, where I got my s is equal to 2. I could have substituted it into the formula over there. I won't get a math error, or my calculator won't tell me, stop, that's not correct. No. Okay, it's possible to substitute it, but that is not the sum to infinity. Okay, so here, now that we know that the sum to infinity exists, the reason it exists is because our r is between -1 and 1. Now I just use the formula to work out what the sum to infinity is. So my sum to infinity, so your infinity is like an 8 that's lying down. Please don't write 8 there, it's not an 8. This is equal to a, your first term, that's 16. Then I divide this by 1 minus a half. So here, this is just 16 divided by a half. This is equal to 32. So try it on your calculator. 16 plus 8 plus 4 plus 2 plus 1 plus half. Even with 10 terms, I'm sure you can see this is getting closer and closer to 32. Then you can try using the SN. Okay, and here you can set n to maybe 100. You can see it is maybe 31 point something. You go n equals to 1,000. You know the formula for that. You will see it's 31.96. 6 maybe, then the bigger your number is, then the closer it is to 32. So this is your check. We have 27, -9, 3, and -1. And we are asked to find the sum to infinity. So again, what we do, we need to check if the sum exists or not. So do not just assume it exists and then substitute into your formula. What you might get might not be true. So what you do is you check, you work out r. You know that r is -9 divided by 27. So this is just -1/3. Now that you have your r, you can take its absolute value. The absolute value of -1/3. This is just equal to 1/3. 1/3 is less than 1, so this passes the test. That is what you need in order for the sequence to have a sum to infinity. So here you can say S to infinity exists. And then now we work it out. The sum to infinity, I'll write down the formula. This is A, which is your first term, divided by 1 minus R. Okay, what is my A? It is 27. And then I divide this by 1 minus R. R, I take it the way it is. I don't use the absolute value over here. I must take the R that I have in the question. Then this, I just work it out on my calculator. 27 divided by 1 minus 1/3. This is 81/4. You can write this to 3 decimal places, depending on how the question is asked. Okay, so this is 20.25 to 2 decimal places. Then this is number 2. We're on exercise 5.3.3 now. Okay, with this one we are told that U3 is 16 and that U3 plus U4 is equal to 8. That means the sum of the third and the fourth term is equal to 8. And then, let me just read it the way it's written here. The third term of a geometric progression is 16. The sum of the third and the fourth term is 8. Find the first term, the common ratio, and the sum to infinity of the progression. Okay, so that one, again, not too difficult. I wrote down what I'm given. I'm told that the third term is 16. The sum of the third and the fourth is 8. Then I'm asked to work out the common ratio, the first term, and then the sum to infinity if it exists. Okay, so here, if I know that U3 is 16, and then I know that U3 plus U4 is equal to 8, I can work out U4. So U4, this is equal to 8 minus U3. So I'm using this equation. But then I know that U3 is equal to 16. So this is just 8 minus 16, which is -8. And now I have 2 consecutive terms. I know that U3 is equal to 16 and U4 is equal to -8. To work out R, I will say this is U4 divided by u3. Okay, so this is negative 8 over 16, which is negative a half. Right, so now that I know what r is, I need to check, does s to infinity exist? But even before that, I can work out the first term. So I use this third term that I'm given. This is a, the first term, and then r3 minus 1, and this should be equal to 16. Okay, so a is what I'm looking for. R is negative a half to the power of 2. And this is equal to 16. So a half to the power of 2 is 1 over 4. This is equal to 16. And then what I do is I multiply by 4 on both sides. I get a is equal to 64. Okay, so now that I know what my a is, and I know what r is, it's over here, I can now check if S infinity exists. So the check is the absolute value of r. This is the absolute value of minus a half, which is just a half, and this is less than 1, so it exists. Okay, now because it exists, I can work it out. So I say the sum to infinity, this is equal to a. My a here is 64. And then I divide this by 1 minus r. R is negative a half. R is not positive half. It's a negative half. And this, you work it out on your calculator. This is 128 over 3. Okay, so very simple to do. Nothing too difficult. Okay, and it's interesting that this 128 over 3, this is 42, and 2 over 3, excuse me, which is even smaller than the first term. And the reason is because some of the terms are positive, others are negative, so they take away from the entire sum. So if both of them were, if everything was positive, then you'll notice that the sum to infinity will be greater than your first term. But because they're alternating, some are positive, some are negative, then you have a sum to infinity that is less than what you started with. Then number 3. Number 3 says you are given a geometric progression, which is y, 2, 4 over y, and p. So this is a geometric progression, and we know what makes a progression geometric, that there is a common ratio. Now we are told to express p in terms of y. Now because this is a geometric progression and we have a common ratio, so I will equate all the different ways of working out the common ratio. So my r, this is equal to 2 over y. This is also equal to this one here, p divided by 4 over y. Okay, I could use the middle one as well, but there's really no need. This is enough. Okay, so taking these two, And what I want is to just express P in terms of Y. Now this one is simple to do, so I have 2 over Y. This is equal to P times Y over 4. Then what you do is you multiply by 4 on both sides. You get 8 over Y. So this is just making P the subject of the formula. And then you divide by Y on both sides. You'll get P is equal to 8 over Y squared. That's it. So this type of question is just testing you. Do you understand what it means for a sequence to be geometric? Okay, and that is the ratio must be common between any two consecutive terms. And number 4, we are told that we have a geometric progression. We have 7, 14, 28, 56, and so on. And then later on in the progression, we have this number 4, 5, 8, 7, 5, 2. Okay, so this number 458,000, it appears somewhere later on in the progression. Now we want to find out what number is it in the progression. Now to work this out, we've done questions like this before. We write the nth term. So we know that an, this is a, which is 7. We can see it. And then r is 14 divided by 7. And then I raise this to the power of r, n minus 1. This is the general formula for the nth term. So I have 7 times 2 to the power of n minus 1. This is equal to 458,752. Okay, so that is what I have, and what I need to do here is make n the subject of the formula. We've done questions like this where you know how to make the exponent the subject of the formula. You can use logarithms, or you get to a point where you write both sides with the same base and then you equate the exponents. So first I will divide by 7 on both sides. So when you divide by 7 on both sides, you're left with 2 to the power of n minus 1. This is equal to, just a moment, okay, and this is equal to, on the other side you get 65,536. Okay, so here you can take logarithms, you can take log base 2, or if you know what this is 2 to the power of what, you can rewrite it. So I know that this is 2 to the power of 16. Now with these questions, because you are told that the number is in the sequence, you can just do a trial and error on your calculator. Start with 2 to the power of 11. It's not 2 to the power of 17. It's not. Then you see, okay, do I need to go up or do I need to go down? Otherwise, just take log base 2 on both sides. That will also work. And then here I have bases that are equal. So it means my exponents are also equal. This means that n is equal to 17. And even if you took logs on both sides, so here I have log base 2 of 2 to the power of n minus 1. This is log base 2 of 65,536. You will see on your calculator here you get 16. N minus 1 is equal to 16, and again n is equal to 17. So choose whatever method you feel best about. With smaller powers of to, it's easy to rewrite them, but if you're not sure, then just a moment. I don't know if somebody's okay. Okay, then number 4, no, this was number 4, now number 5. Number 5 says find the sum to infinity of the GP having a second term. So we're told that the second term is equal to -9, and the fifth term, U5, this is equal to 1/3. So we're told to find the sum. Now the way to do it, to find the sum to infinity, what we do is we find A, we work out R, and then we check, does the sum to infinity exist? Usually when the question tells you to find the sum to infinity, it means it exists. Otherwise they would say find the sum to infinity if it exists. Now here we're told to find it, so more than likely it does exist. Now what we do is we're going to form two simultaneous equations. We know that A R2 minus 1, this is equal to -9. This is the formula for the second term. Okay, and can substitute or rewrite this. This is AR, this is equal to -9. This is the first equation that I have. Then I use the formula for the fifth term. I have the fifth term, this is A R4 minus 1, and this is equal to 1/3. So rewriting the equation, I have A R to the power of 4, this is equal to 1/3. So that's what we have. Then with these two equations, I will divide them to get rid of the A, and then so what I have is this A R to the power of 4, this is equal to 1/3. Then I divide it by AR and -9. Okay, so here what I will have, the A's will cancel. Then I have R to the power of 3. Remember your laws of exponents. You should subtract the exponents if your bases are the same and you're dividing. And this is equal to -1/27. Then you just take the cube root on both sides. You have R is equal to the cube root of -1/27. And this is equal to -1/3. Okay, so it's always good to test, does the sum to infinity exist? So the test is that the absolute value of R, which is the absolute value of 1/3, which is equal to 1/3, is less than 1. So this sequence passes the test, so the sum to infinity exists. So we'll work it out, the sum to infinity, this is equal to A. What is my A? It is, I didn't work it out. I'm skipping steps. Sorry, we still need to work out A. Now I know what R is. R is -1/3. Now to work out A, I use this formula. AR is equal to -9. But R here is given over there, so I have A times -1/3. This is equal to -9. just divide by negative 1/3 on both sides. So you get A is equal to positive 27. Okay, because it's negative dividing a negative, your answer should be positive. So now I have everything I need. I've already checked that the sum to infinity exists. The only thing left for me to do now is to work it out. So the sum to infinity, this is equal to A over 1 minus R. Now my A here is 27, and I divide this by 1 minus my R, which is negative 1 over 3. And then this, I just check on my calculator, this is 81 over 4. Then number 6, we are told to find the first term of the GP when R is equal to 3 over 5, and we are given the sum to infinity, which is 40. So here is just solving an equation. Write down the formula for the sum to infinity. This is A over 1 minus R. We know this is equal to 40. We know what R is. It's 3 over 5. And it does exist. It makes sense that it exists because my R here is less than 1. The absolute value of R is less than 1. So it makes sense. Then I just substitute everything. So I have 40. This is equal to A over 1 minus 3 over 5. And this is equal to the sum to infinity. So we just solve for A. So I have 40. This is equal to A over 2 over 5. And then you will multiply by 2 over 5 on both sides. And what you should get is 16. And A is equal to 16. That's 16. Is that what you get on your calculator? Can you check that? Multiply this by 2 over 5. It should be 80 over 5. Yeah, it should be 16.
Yeah, it is, ma'am.
Okay. So the questions are not always going to be just work out the sum to infinity. I could give you 2 of the other variables in the equation, and then you have to work out the other one. Then number 7, we have to find the common ratio where the first term A is equal to 5 and the sum to infinity, and this is equal to 15. Okay, so what we're looking for is R. So here again, you know our formula, S to infinity, this is equal to A over 1 minus R. Now here, because the sum to infinity exists, if we get an R whose absolute value is greater than 1, then we know that we've done something wrong, because the sum to infinity to exist, it means that our absolute value of R should be less than 1. So I'll substitute. This is 15. My A here is 5. So what I have is 15, 5 over 1 minus R. Okay, then you can cross multiply, so you have 1 minus R. This is equal to 5 over 15. Okay, so you multiply by 1 minus R on both sides, and then you divide by 15 on both sides. So you have 1 minus R. This is equal to 1 over 3. This means that R is equal to 2 over 3. And you can see my absolute value of R. So this is just something I check in my mind just to see, okay, I know I'm on the right track. This is this is less than 1. So it does make sense that the sum to infinity exists and it is equal to 15. Then we have number 8. Number 8, we are told that the sum of the first two terms of a GP is 9 and the sum to infinity of the GP is 25. If the GP has a positive common ratio, already this is a clue telling you that you're probably going to get two values for R, but you must take the positive one, something like that. Find R and the first term. So we write down the information we're given. We are told that A plus U2, this is equal to 9. Now I can rewrite this where everything is in terms of A and R. Now I know the second term here, I can rewrite it as A times R. That is the formula. So I would say 2 minus 1, but 2 minus 1 is just equal to 1. So this is what I have, like that. So what I do is I can factorize A out. So A 1 plus R, this is equal to 9. And then I divide by 1 plus R on both sides. I have A is equal to 9 over 1 plus R. And then I was also told in the question that the sum to infinity, and this is equal to 25. Okay, so this is what I was also told. And I know the formula for the sum to infinity. I have 25. This is equal to A, but my A is this one here. So I say 9 over 1 plus R. And then I divide this by 1 minus R. So you can see over here, I now have one equation where everything is in terms of R. So all I need to do is work out what R is, and then I will come back and substitute it in there to find the value of A. So here I have 25. This is 9 over 1 plus R. This is divided by 1 minus R. So I'm rewriting this with a division. So this division will change to multiplication. So I have 25. This is 9 over 1 plus R multiplied by 1 over 1 minus R. Then look at your denominator. That becomes the difference of squares. So you have 25. This is equal to 9 over 1 minus R squared. So 1 plus R multiplied by 1 minus R. That is the formula for factorizing a difference of squares. Then what you do is you will cross multiply. So you have 25, 1 minus R squared. This is equal to 9. Then you multiply out to brackets. You have 25 minus 25R squared. This is equal to 9. Then you make R the subject of the formula. You say negative 25R squared. This is equal to 9 minus 25, which is negative 16. Divide by negative 25 on both sides. You get R squared. This is equal to 16 over 25. Then you take plus or minus the square root. R is plus or minus the square root of 16 over 25. R is plus or minus 4 over 5. But then you have to remember what the question said. The question said that R is positive. So since R is positive, according to the question, then R is just equal to 4 over 5. So you show me all the calculations, and then at the end you make a conclusion on what your value of R is. Okay, so now that we know what R is, we are asked to work out the first term, and A, this is equal to 9 plus over 1 plus R, which is 4 over 5, and this, we work it out, you get 5. Okay, so that is how you would do that one. So nothing difficult or complicated about that. So it's just about understanding the question, see the information that you're given, and then work out what it is you're asked to work out. Okay, and then the last thing in this chapter is on sigma notation. Okay, now sigma notation, sigma first of all is written like that. Sigma is a Greek letter and we use it to denote a sum. So instead of writing A plus U2 plus U3, instead of writing this long sum, what we do is we can shorten it by using sigma, because sigma means a sum. Now you'll notice with your sigma, you have limits. So you have, for example, R is equal to 1n. This is your starting point. And this one here tells you where to end. Okay, so it's easy to look at an example. Let's say we have the sum where A is equal to 1 to 4 of A squared. Now what is happening over here is that you will substitute A, you start with 1 and then you end at 4. So everywhere you see A in, why did I write it like this? It's not A squared. Okay, so everywhere you see A, you will start, substitute 1, then 2, then 3, then 4, which is your end point, and then you add everything together. So this just means 1 squared. So you can see I've substituted A with 1, and then the next number after 1 is 2, so I have 2 squared. The next number after 2 is 3, so I have 3 squared. Then the next number after 3 is 4 squared, and then I stop. Notice that the 2 is not changing because I don't have an A over there. I have a 2, so I'm only substituting whatever letter I am given over there. Now this one is easy to do on your calculator. This is 1 plus 4 plus 9 plus 16, and this should be equal to 30. Okay, so this is just substituting. This is the long way of writing it, and this is the shorter way of writing it. Let's look at another example. We have K is equal to 2, and we end at 20. And what we are substituting K in is this formula, 10 minus 2K. So if I wanted to write the long way of writing the sum, I would say 10 plus 2 times 2. This is my starting point. Then I add that. So this is the first term. Then I add that to 10 plus 2 times 3. That is the second one. And then the third one, I would say 10 plus 2 times 4. And then I would keep adding until eventually I got to 10 plus 2 times 20. There's 20 over here. That is my end point. And then that is how I would do it. But now you notice that with 20, it might not be too difficult to work this out. We have 20 terms, but sometimes I could give you 1,000 as your end point, and writing down all those 1,000 terms will be quite tedious and it'll take you quite a long time to do. So what you do is you need to recognize that this is a formula for an arithmetic progression. Now, if I have the formula for an arithmetic progression, I can always work out the sum of any given terms. So what you do is, excuse me, what you need to do is you need to know what your A is, because that is what you use in the formula. You need to know what your D is, and then you need to know how many terms you have in the sequence. Now, if I look at this, my A will be this term here when K is equal to 2, because I listed them and it was the first one. So this is just 10 plus 2 times 2, which is equal to 14. And now D, this, I can work out the second term here. This one will give me 16, and this will give me 14. Did I write this correctly? Let me see. Okay, yeah, my formula is not, this plus should be a minus. Okay, so my first term is not even 14. So we should have 10 minus, excuse me, 2 times 2. This is actually equal to 6. Okay, then I could also work out the second term over here. I say 10 minus 6, and then I will get 4. So my first term is 6, the next one is 4. The common difference is just 4 minus 6. Then what I do is, here I can say my common difference is negative 2. But even just by looking at the question that I am given, this number here in front of the letter, whatever letter I have here, that is always what your D is equal to. Okay, so I can work it out in this way. I work out the second term, I know what the first term is, I subtract them, or I could just look at it. Just by looking, the term that is the coefficient of your variable is always your value of D. So D is equal to minus 2. And then now N is how many terms do you have? Here I'm starting from 2 to 20. Can somebody tell me how many terms do I have here?
Ma'am, you said you are starting from the second term to the 20th term,
Yes,
and you ask how many terms are they?
yes.
Can I say 19 terms?
How did you get 19? Because somebody might say, isn't it 20 minus 2? How did you get 19? Okay, he doesn't want to tell us, so just take it, I guess. It's 19. Okay, so there are 19 terms over there. Then now you have everything that you need. Now we are working out the sum of the first 19 terms. It's 19. This is equal to, we know the formula, it's 19 over 2. Then we multiply this by 2 times your first term minus 2, not 2, this is n, which is 19 minus 1 times d, which is minus 2. So this, you just work it out on your calculator, not very difficult to do, and you should get negative 2, 2, and 8. Okay, then the next one, we are told to write a series in sigma notation. So we have this one, 5 plus 9 plus 13 plus 17 plus 21 plus 25 plus 29 plus 33. Okay, so we are told to write it in sigma notation. So I must have this. I need a starting point over here. I need an end point over here. And what goes over here is just your formula for AN. That's it. So if you work out what AN, that is what you're going to substitute over there. So I should work out the formula for AN. My first term in the sequence is 5. So I know that my A is equal to 5, or UN. Yeah, sorry, I'm using UN. It's UN. Then what I need is the common difference. So I take any two consecutive terms, 29 minus 25, that is equal to 4. So D is equal to 4. Then I write down the formula for the nth term. So I say UN, this is equal to A plus n minus 1 times D, which is equal to 4. So this is equal to 5. The 4 will multiply inside. This is 4n minus 4. And this is just 4n minus plus 1 plus 1. Okay, so I can write this down. This will be 4n plus 1. So I need my starting point and my end point. My starting point is 1 because I'm taking the first term, and then my end point is just how many terms do I have inside this sequence. So here, because the terms are all listed, I can just count them. Say 1, 2, 3, 4, 5, 6, 7, 8. So my end point is just equal to 8, like that. And then you are done. Okay, so exercise 5.3.4, that will be your homework for today. Exercise 5.3.4, that will be your homework for today. Go and try them. That's the last exercise on this chapter. So we should be done with this chapter by tomorrow, and then we will revert very quickly go over the graphs. So that is the straight line and the parabola. Do we have any questions before we go? Okay, if there are no questions, have a good day, and I will see you guys tomorrow.